Hello everyone, welcome to this lecture on Lambda hands-on. This video is going to be the continuation of the Lambda theory which we have studied just now. So the objective of this demonstration is we are going to upload an object into the S3 bucket, and that object upload operation is going to trigger the Lambda function. This is one of the functionalities in which Lambda is used. Remember, it's used as a trigger. So let's quickly create a Lambda function into the Lambda console. There are three different options when you are going to create a Lambda function. That is the author from scratch, where you code your own Lambda function and select your own runtime, that is the runtime language you want to use. Or you can use a blueprint, which is some sample codes which are provided by the AWS itself, and it has different connectivities with Kinesis Firehose or DynamoDB and RDS and S3. So these type of operation, that whenever a get object is there in the S3, it will trigger a Lambda function in Python. See, and Amazon S3 trigger that retrieve metadata for the object that has been uploaded. Okay, and then the last one is browse serverless app repository. So we will use author from scratch. Let's give it a name because we are going to trigger it from S3. So we are writing as S3 trigger. The runtime is the different languages like C#, PowerShell, Go, Java, Node.js, Ruby, Python. For this video, we are going to use Python 3.8. And the permission is that this Lambda as a service is going to access some other resources, some other services. So for that purpose, this Lambda also needs some set of permissions. That is a policy which has a restricted access to those services. So I've already created a Lambda, an IAM role for this one, which is called as Lambda access. If you go here and see in the IAM console, you can see here it has Amazon S3 full access. So let's quickly create the function. Apart from the, I just remembered, apart from this S3 access, the Lambda function also needs to write logs into the CloudWatch. So it also needs CloudWatch access. So I'll attach one more policy, that is a set of permissions. I will search here CloudWatch. If you see, we have CloudWatch full access. So for that IAM role, I will attach two different policies, that is S3 full access and CloudWatch full access. They both are being required by this Lambda function. Now if we move back here and see, we have a Lambda function. This is the place where you can write your piece of code, your logic as per your requirement, that will be executed when an object is uploaded, that is object is put, or maybe in another scenario when an object is deleted from the S3 bucket. Okay, so you can write your code here. Also, if you don't want to write here and you have it on your local, you can upload a code in a zip format, in zip file, and also you can upload the code from S3 bucket. So these are the three different options from where you can actually run your code. let's quickly, this is the default code which is being provided by the AWS, so it will just return a hello from Lambda. Meanwhile, I will add one more line here, which means Lambda is running now. It's just for the sake of sending like a message to the user that the operation in S3 has in turn like executed or invoked your Lambda function. So the user will come to know that my file has arrived. You can assume it as a file watcher in your regular projects, right? So whenever an object is received in a file, you have to trigger some logic. In real world scenario, you won't find this type of very simple logic, but actually there will be more complex logics, like you have to do some file validation, you have to do some data validation in these codes. You have to write these things into your Lambda function, but that thing you will be doing as per your project requirement. So we are not going to cover that. We are just going to print a simple message that is Lambda is running now. Let me quickly add a trigger. So it's not only the S3 which can trigger the AWS Lambda, but there are many services which can trigger the AWS Lambda function. For our particular demo, we are using AWS S3. Now we are going to use the bucket, that is mytest1121. Then we want the type, event type, right? So the event type is going to be what type of operation is going to happen on your S3 bucket. Is it going to be all the create events, like a new event is put, or it is being copied, or a multi-part upload? Like multi-part upload is something like a bigger file is uploaded in parallel in chunks, like 100 GB file is there, so you upload a 20 GB file, 20 GB, and in this manner, right? Also, it happens for delete events also. Suppose you have deleted a file, a user is no more existing, and you delete the user's file. It should also trigger the Lambda function and inform the end user that this user is now deleted. So these type of flexibilities is given. For our sake, we are using all the create events. Prefix and suffix, this is a bucket level operation, so you don't want to do this operation for all the files in the same bucket, right? So what you can do, you can give a prefix that all the files which are having a prefix like dev, so all the dev environment files, dev underscore customer data, so all the files which are having prefix of dev will come under scope and rest will be discarded. In the same manner, if you want all the text files or .jpg files that should be used as a trigger, in that case you can give the suffix. So you don't have to worry about like all the files here. You can segregate your set of files on the basis of prefix or suffix. Okay, so for this demo, I have left this blank and we will be using the whole bucket. Let's add the trigger. So now the trigger is added. So as you can see, it is connected here to the Lambda function. So whenever an operation, that is a put operation or new object, is added here, it should trigger this Lambda function, which will run this particular code. We will save this and let's explore some other features which are there in AWS Lambda before we run it. This is very important, the environment variables. So in the real project scenarios, you don't want to hard code your values in your project, right? So suppose you have to pass a date or a client's ID. So for testing purpose, sometimes you can hard code it, but when you have to deploy it, you have to add the environment variables. So they appear in a key value pair. I will add in one. Suppose I want to add a date. I will write a date. Now I will give like today some date like this. Okay, and this date will be called in the Lambda function. So you don't have to change your code every time as per your test cases, but you will pass the value inside these variables. So this is quite handy when you are going to code it. The second use is of reusability. You can understand something like this, that you have one Lambda code which is writing something into your RDS tables. So it must be having the connection of those tables, right? Now you have one code and you have four different environments. You have dev, your SIT, your U8 and production. So one code and four different variables for different environments you can create and pass them as per your requirement. In which environment you want to run, you can just pass them. So this is the use of environment variables. For this sample demo, we are not using the environment variables. Now, if we go here, we have some monitoring tools where we see some metrics of the AWS Lambda when they're executed, like the number of invocations, the total runtime, the CPU utilization. These type of metrics are being captured by the CloudWatch. We will see it very soon. Let's check some basic settings also. You can add a description for your Lambda job, which helps the end user to read what exactly this function is doing. You can also change your runtime, that is the language in which you want to run. These are the languages available. Also, you can allocate the memory, right? So for default, it is the minimum memory which is given, that is 128 MB, and you can increase it in the increments of 64 MB. Here you see, and that the maximum you can reach around is 3 GB. We will keep it minimum. You can give the timeout also, and you can change the role which is being assigned to this IAM function, this Lambda function. You can create new roles in the IAM console and attach it over here as per the requirement. Suppose later on I have been, like in this example, I am accessing S3 and writing the logs to CloudWatch, but in some later point of time I have to also write the metadata into the RDS table or DynamoDB table. In that case, I also need access on those DynamoDB tables, so I will create the Lambda role for that, attach the policy here, and then attach that role in this Lambda function. I will discard these changes. So we have saved this, and we have a sample code that whenever it is invoked, it should write as Lambda is running now. So we will test this. As we are not passing or we don't have any test cases, it's a simple program, so there are nothing to pass. We will create a test case and we will run it. So here you see, these provide the details of your Lambda function once it is executed, and this is the log output, and it says Lambda is running now. So even though it was not created as a trigger from S3, but we have manually tested this Lambda function. So we'll quickly go to the CloudWatch and check. The logs must be here. You can see the logs are generated in CloudWatch. We'll open this and we'll see the latest one. And here you see, we have Lambda is running now. So there are some details which are of much importance, that what is the output of the Lambda function, the requester ID, okay, then for how much duration. So if you can see, it's ran for 1.57 millisecond, but as per the theory lecture, you have to remember that it has to be built for the minimum of 100 milliseconds. It also gives the memory requirement which I have utilized. So I have utilized around 52 MB even though I have allocated 128 MB here. Let's quickly move back and delete this log, and now we are going to run it directly as a trigger. We will delete this log. So now you have no instance or nothing of this Lambda function. I have deleted this log, and now ideally when I should upload this a file into this S3 bucket, that is my test1121, it should trigger the Lambda function and the logs should be generated here. So for this purpose I have a dummy file which I am going to upload into the S3 bucket. See, the file is uploaded. This file is now acting as a trigger. It doesn't matter about the existing files, you have to remember this. Only the new file which is being added here. So my Lambda function must be triggered. So in this console we can't see because we have not tested it. We have to go and check into the CloudWatch console. We will quickly refresh this and see the Lambda function is triggered because we have uploaded a file in the respective S3 bucket. Let's open this. And here you see Lambda is running now. The same message is appearing, but this time it was created from the this S3 upload operation. So the S3 has triggered this Lambda functions. So in your project there might be different scenarios where you upload a file in the S3 bucket, then you need to copy it to another S3 bucket after validation, or sometimes you need to extract certain columns, or sometimes you have to do a data validation on those columns. So these are the real-time project scenarios, and you have to look in the Python or whichever language you want to code it. Also, there are different methods in which you can integrate your Lambda function with DynamoDB or an RDS instance. That we will learn later on. So this was a lecture and a complete hands-on how S3 triggers are utilized to invoke the Lambda function. If you have any doubts, do comment and let me know. Till then, happy learning. Bye.